Cool. Well, hey everyone, it's Calvin, and today I'm going to be walking you guys through a project I worked on um, called Brownian. So, what Brownian is it's a stock portfolio analyzer. So, I worked with my friend Bryan on this, and Brownian, you can read the README, but it allows users to manage a theoretical portfolio for risking real money, and it allows users who already have a real portfolio to manage it more effectively by presenting detailed analytics about their portfolio's past and projected performances. The main technologies that I used here were Python, pip, Flask, JavaScript, React.js, NPM, Webpack, CSS, HTML, D3, SQLite, and React Router. And here's instructions for building the application. And cool. If you're interested in this project or want access to the repo, feel free to shoot me an email or DM me on LinkedIn. I'll kind of show you guys the app now. So first thing we need to do is start the server. So I'm going to start my virtual environment and then run the server. And then I gotta allow. Then I need to build the front end. So let's wait for it to build a little bit. Cool. Let's take a look. So Brownian. This is our homepage. So front end, again, as I mentioned earlier, built completely in React. Talks a little bit about what is Brownian. So it's a risk analysis tool that helps you manage a portfolio. My friend Bryan that I worked on this with, he's going to be working at BlackRock, and he used to work there. So he has the more financial expertise, while I did most of the more on like the front end development and like data visualization, while he was more on the back end database, API connections, and all that jazz. So this is some finance stuff that Bryan wrote about reducing risk and how to use Brownian. Also a graphic that Bryan designed. So the nav bar here, it's done in React Router. So I'm logged in. But the gist is like it's done in React Router, right? So each route has its like page, and like the way I set it up, the way I set React Router up was if you haven't logged in, then you're not able to kind of access the other pages. Like it'll continue to keep you at the login sign up page until you provide your credentials. So it like emulates that real feel where you can't see the sensitive information without logging in. So I did that in React Router. So I got stuck here. I can still access the homepage though. So let's say if I log in, right? And if I put the wrong login, it won't go. The wrong password, sorry. But if I put the right password, boom. This is the manage page right here. So I'm able to see two things here. So portfolio, my current portfolio, as well as the optimization tool. So this high-level overview is that this is like the current stocks that I'm holding, and this is like kind of how my portfolio is doing. And this is like the current stocks that I have, as well as how much of each stock I have, what's the value, what total value, and this is like how my portfolio is doing, how volatile it is, the Sharpe ratio. And this is like the optimization tool. Basically, it takes the stocks that I own, and it in a way Bryan handled the financial analytics part of this, but it takes the stocks that I own and optimizes the possession of those stocks. So if we look at like here, the optimization tool is saying like, oh, don't purchase any SPY stock. And the optimization tool also has its own set of returns, volatility, and Sharpe ratio, so that I can compare how the optimized portfolio is doing with my portfolio. And right now it's doing a lot better. And right here, I can change what I want the optimized portfolio to do. So right now, I think it's default maximize Sharpe ratio. But But if I wanted to minimize volatility, for example, yeah, see, I can like swap it back and forth. So if I wanted to minimize volatility, it looks like I want to buy a lot of SPY and less Apple. But if I want to maximize Sharpe ratio, it's looking like I'm not gonna get SPY at all. And yeah, and it updates dynamically. These data bindings were done in React, so changing like one thing will update the table accordingly and update this holdings table down here. And if, for example, let's say, minimize Sharpe ratio, this I like what the optimization tool is doing for me here. I can bring those changes into my portfolio. I can say, boom, I like it. And now my portfolio has what optimization portfolio has. And let's say I changed my mind. I want to minimize volatility. And then I was like, and then I changed my mind and I say I want my portfolio to look like that instead. Hit update portfolio again and updates. And another cool feature we have is we have undo changes. So undo last change, undo last hour, undo today. If I do, boom, I'm back at. I didn't do much in the last hour, but yeah, you can basically undo changes. Very cool. If I want, I could also clear holdings. Boom, this is gone. And if I want to undo that, boom, that's back. So clear holdings, and then I can if I want, I could build my portfolio from scratch. Let's say I want one Google, boom. Let's say one Facebook, and let's say, and see the optimization tool is kind of like real time, showing us with the stocks we pick, what is the best allocation for each of those stocks. Tesla, I want one Tesla. Of course, Elon is the GOAT. Let's say I want Elon's the GOAT, so 2 Teslas. It updates dynamically, and the colors match up between these two so that we can kind of visually see our changes and how the optimization tool is doing things differently compared to what our portfolio is doing. Sweet. Yeah. So some technical things that I'm going to talk about a little bit more. So one of the challenges I faced in working on this project was doing these visualizations. So these visualizations are done, as I mentioned earlier, in D3. And I don't know how much you guys would know about how D3 and how React work, but React kind of relies on manipulating kind of auto re-renders based on state or prop changes. So React kind of likes having access to the DOM so that it can kind of re-render things on its own. So when I code with React, I don't really touch the DOM directly. I just I touch the data in React, and based on data changes and data flow, React kind of knows to re-render the DOM in an efficient manner when that data changes. But the thing with D3 is that D3 likes, as opposed to React, which updates the DOM on its own, with D3 I kind of need direct access to the DOM, and I want to do everything directly with the DOM. And then the code in D3 code, I need to tell the DOM exactly how I want it to look. Whereas with React, I just kind of I let React do the DOM updates. Where in D3 I need to get into the DOM. So I was having trouble thinking about how to integrate. First off, what kind of data viz tool to use, and what kind of data viz tool would be best with React. And I looked at a few alternatives, but I eventually went with D3 because it's widely documented. It's very powerful, and it basically has a lot of capability in terms of data binding and data joining. And these are capabilities that I ended up using quite heavily in the end. So that's why I went with D3. Also, it's written in JavaScript, so I was pretty comfortable in JavaScript at the time. And I think the big thing I had to make sure was I did some research online, and it seemed that if I were going to use D3, I'd have to make sure that React and D3 kind of both get their own room to play. And I guess in a way what I mean by that is that each one kind of needs space to breathe and space to have control over what it wants to do. And again, if you're interested, shoot me a DM, and I'm glad to share the code with you or talk more about what it kind of looks like and kind of share the internal details. But the way it worked was I created this visualized component in React. This visualized component kind of encapsulated all the D3 logic, and basically React didn't know that D3 was there, and D3 didn't know that React was there. Like, all React was doing was handling the data and the data changes, and when the data would change, the React ecosystem would ping the visualized component using component did update, and would say, hey, the data changed, trigger the D3 update. And so in the D3 JavaScript file, I wrote vanilla D3, and just like it looks basically exactly like how normal D3 would look outside of a React application. And in the React side, I wrote normal React, just looks exactly like how React would look normally. And so I think by giving the D3 room to breathe and the React room to breathe, and kind of walling them off and letting them have space to have control and autonomy over like their respective areas, I was able to create a cohesive communication and understanding between the two technologies, so that they wouldn't step on each other's feet and mess up each other's flow, because they both function in different ways, and like if they stepped on each other, it would cause some, I think, some pretty nasty bugs. Now, yeah, for the D3 thing, take a look at it real quick.
Cool. So now we're going to look at the D3 React interactions in the code. So the way I set it up was that in the React code, we have a component called visualize stocks, and this visualize stocks component basically does the job of rendering, it does the job of rendering this pie chart here. So we have visualize stocks, right? And we give visualize stocks something called this.props.items, and this.props.items is basically a list of all of the stocks, their price, how much of each stock. It's basically all the stock information. So visualize stocks, when we take a look at visualize stocks, it doesn't really have much in it. I would consider it the wrapper for the D3 functionality, and we can kind of see that here. So this visualize stocks component, when it mounts, it draws it, and when it updates, that's basically when a stock updates, then it'll update, and it's only rendering a div. So the key thing here is that both of these functions are coming from a JavaScript file. So they're vanilla JavaScript, vanilla D3, and we're using it in React to initially draw, and then after that, continue to update our visualization as the data, as React detects data changes or prop changes. Okay, so we can look at this is where the D3 code lives, in visualize stocks. So we take a look at visualize stocks. It's vanilla D3, as I mentioned earlier. So we take a look at first the draw function. So the draw function, it's fairly typical. It's I looked at some various code samples online on how to build donut charts, and I used it for the draw function. I kind of used various code samples online and tweaked them a little bit. So yeah, the draw function didn't give me too much trouble, I'll say. I think a lot of the trouble came in this update function. So D3, a lot of where its power comes from is that it's, as I mentioned earlier, it's data binding feature. So like this update here, so like when the stocks update, we want to call update, and we want this update function, which comes from visualize stocks. We want that to be able to re-render the pie chart in an efficient manner, and also in a manner that supports the animations. So how do we do that, right? So that's, I'll give a brief overview, but the D3 data mining is very powerful and complex, and I encourage you to look more on your own. But the gist of it is that every time we have like an update, our stocks update, right? It's gonna call the update function with the new stocks. So the update function gets the new stocks in here. And then what we do, first of all, is that this value thing here, it helps give us like the new proportions for the new pie chart we need, and it kind of sets the slices based on total value. The key parts here are it's basically when we have this new data, D3 has something called like selections, and we basically in D3 we need to select the existing slices before the update. Because basically in D3 we have this idea of like we have these DOM elements, in this case like the pie charts right here, the pie slices, these are the DOM elements, and then we have like our data set in this case, which is the stocks table. And D3 kind of helps us in a neat way figure out like, oh, when our stocks data set changes and it's not in line with what the DOM is showing, then D3 kind of knows how to fix that in a smart way. So with D3, the key thing to know is that like these DOM elements, these pie slices in the DOM are connected and bound to the data points in the stocks data set. And that's because in the code, when I initially draw the pie chart, I bind the data. So here's my data ready, and then so I bind the data here. So I take the data ready, and this function essentially I want to differentiate each stock by its ticker, and I want to tell D3 that. So here's where the data binding initially happens, right? So now each DOM element at the initial point, each DOM element has a data point associated with it. And then when it updates, here I have data ready again. So now first I want to existing slices is like kind of all the slices that were there before, prior to this update. And now I'm binding that kind of existing slices with this new data. So my new data might have some discrepancies with the current DOM elements. So then we move to resolve that in the code. So here's a transition. So this enables the animation. The arc-tween kind of enables smooth transitions between different pie slice size. So yeah, that's kind of the animation. Here, this new slices selection is, so when we call enter and append path, we're basically saying that like, oh, since we bound our DOM elements to the new data set earlier, when we call enter append path, we're saying like, oh, whatever new elements in our data set that currently don't have an associated DOM element, we want to add a new DOM element for that corresponding data point, and we'll make it a path element. So we append a new path element for each new data point in our data set. And here, all slices, this is a selection of all the slices. So we merge new slices with existing slices. And what we're doing here basically is that at this point we have our existing slices and our new slices selected, and then we give it the attributes that we want to give all the pie slices. So this is like the arc size, this is color, stroke, opacity, etc. And here what we're doing is this is a very important step as well. So this is how we enable things like, so in this case, if we go FB0, like it animates, like knows how to do that, knows how to take care of that. And that's because this line here, so existing slices.exit, this gives us a selection of, so basically when at this point, right? So FB, we have 2 Facebooks in our stock data, in our stock props. And then when we call 0, then we have 0 FBs, but technically like what will basically happen is that like, oh, our data set will update first, and it'll say, oh, we have 0 Facebook stocks. And then it'll ping the update here, because it'll hit the component did update, and it'll ping update here. And then when we go here, existing slices.exit basically says like, oh, are there any elements in the DOM that are there, but the corresponding data point that it was associated with in the data set is no longer there. So kind of like, oh, did we remove, like, since we removed Facebook from the data set, the Facebook data point from our data set, the pie slice that's associated with that will get selected by this existing slices.exit. And it's very powerful because it actually selects everything that changes. So like if I remove many data points from my data set, existing slices.exit will be able to select all of those DOM elements, pie slices, pie slices in this case, in different visualizations, it'll be different things. Existing slices.exit will select all of those DOM elements that no longer have that whose data point has been removed from the data set. And then this .remove actually is able to remove that DOM element. So that's how we get this to happen, basically. Cool. Visualization posed a hard challenge, but was fun to dig deep and dive deep into D3 and how its data binding works. So definitely would be happy to work with D3 in the future again. Cool. I'll talk more about visualize now. So also done in D3. These are two component historical graphs. What that basically means is that I'm comparing portfolio's historical performance to the benchmark S&P 500. We have some neat tooltips to see how your portfolio is doing. 1200, it's worth 1800 today. Then how much is it worth here? 2400. Sweet, that's awesome. So we're a lot more volatile than the benchmark S&P 500, but expected. So benchmark S&P 500 is kind of stable. And then down here we have historical statistics. So we have the returns on both my portfolio and the benchmark, so we can compare them side by side. We have the highs and the lows as well. So pretty detailed analytics for you to kind of see how your portfolio is doing. So yeah, I would say in this project, my role encapsulated was a lot of the two biggest challenges I would say were incorporating D3 and learning D3 in a meaningful way to integrate it in our application, and as well as kind of data engineering, the React side of things, and kind of figuring out like how data should flow through each component such that it's dynamic and quick to re-render. So I handled a lot of kind of passing data between components and figuring out how the components should talk to one another such that they all have the information they need to display the information they need. Sweet. I had a blast working on this project. I got to learn not only D3, not only React, but also I got to mess around a lot with React Router, which was a lot of fun. React Router is super complex, and I'm also excited to work on it more in the future. But also, yeah, I had a lot of fun because this was really interested in finance, and this was kind of my first chance to kind of build a tool that could help people like me who don't know much about finance but want to learn more. So had a great time. My partner Bryan was great. So yeah, I'm glad this project came to fruition. So if I log out, back to the home page, and I'm stuck here. I can only access home and login. So cool. Thank you all for listening, and have a great day. Kalvin is out.